Hello everyone, myself I am Rani. Today I am going to give presentation on Hans Peter Lund and the birth of hashing algorithm. Let me introduce. I am Rani. I am studying at Institute of Aeronautical Engineering. So top contents are introduction, scientist Hans Peter Lund and birth of hashing and types of hashing hashing algorithms used for, and conclusion. So let's see introduction. Hans Peter Lund invented hashing. He was continuous scientist in IBM researching the field of computer science and information science. A hashing algorithm is a mathematical function that grabs data and makes it unreadable. Hashing algorithms are one-way programs so the text can't be unscrambled and decoded by anyone else. And that's the point. Hashing protects the data it reads, so even if someone gains access to your server, the item stored there remains unreadable. So here Hans Peter Lund, who invented the hashing algorithm. So actually he was a scientist in IBM researching in the field of computer science and information, and here the hashing algorithm is nothing but making by using some mathematical expressions which grabs the data and makes it unreadable, and it is undecodable form. And here hashing algorithms are one-way programs, so if the data is unscrambled and undecodable, if in the case other person has been hacked your data and he cannot decode the data, if he gets the data also, but he cannot decode the actual information in it, actual the data in it, he cannot decode or unscramble it. So let's see the history of Hans Peter Lund. So Lund was born in Berman, Germany, now part of Wuppertal, on July 1st, 1896. After he completed secondary school, Lund moved to Switzerland to learn the printing trade so he could join the family business. His career in printing was halted by his service as a communications officer in the German army during World War I. Lund spent greater and greater amounts of time on the problems of information retrieval and storage faced by libraries and documentation centers, and pioneered the use of data processing equipment in resolving these problems. So actually Hans Peter Lund is born in Germany in 1896, and after completing his secondary school he moved to Switzerland, and there he started the printing trade, started to learn the printing trade, and his career in printing trade was halted by his service as a communications officer in the German army during World War I, and after that he has spent more time on uh, solving the problems of information retrieval and storage faced by libraries and documentation centers, and pioneered the use of data processing equipment in resolving these problems. Solin was the first or among the first to work out many of the basic techniques now commonplace in information science. These techniques include full text processing, hash codes, keyword in context indexing, auto indexing, automatic abstracting, and the concept of selective dissemination of information. Lund was a pioneer in hash coding. In 1953, he suggested putting information into buckets in order to speed up search. He did not only consider handling numbers more efficiently, he was applying his concepts to text as well. Lund's methods were improved by computer scientists decades after his inventions. Today, hashing algorithms are essential for many applications such as textual tools, cloud services, data intensive research, and cryptography, among numerous other uses. So, today hashing algorithms are used in cryptography and cloud services also. It is surprising that his name and contributions to information handling are largely forgotten. So he was the first among the first who invented the hashing algorithm, and these hashing algorithms can be used in full text processing, hash codes, keyword in context, and auto indexing, automatic abstracting, and and the concept of selective dissemination of information. So he is the first person to who given the idea to put the buckets in order to speed up the search. So he was applying his concepts to text as well, not only numbers. He was also trying to apply the method of hashing code to text as well. So Lund's methods were improved by computer scientists and decades after his invention. So today hashing algorithms are used in cloud services and cryptography also. Cryptography in the sense the it is the same like uh, making the data unreadable form by applying some mathematical or logical expressions. So it contains two types, that is encryption and decryption. Encryption in the sense the plain text is converted into unreadable form, and the decryption in the sense the unreadable form is converted into plain text in the sense readable form. So encryption and decryption are in cryptography, which protects the data from intruders. Among numbers of the species, it it is surprising that his name and contributions to information handling are largely forgotten. Birth of hashing. In early 1953, Luhn had written an internal IBM memo in which he suggested putting information into buckets in order to speed up a search. Let's say you want to look up a telephone number in a database and find out whom it belonged to. Give the telephone number first. Anyway, the telephone number will be 10 digits, right? So here we took for example, we took 314159265. A computer could simply search through the list one number at a time until it found the relevant number, relevant phone entry data. In a database, millions of numbers, so this could take a while. So this could be a drawback of that searching, and for this he invented the hashing. So let's see what the idea of this. Luhn's idea was to assign each entry to a numbered bucket as follows. The four numbers digits were grouped into pairs. In this case, 3 1. So here we have to 10 digits number, that is 314159265. So let's group the two numbers. So 31415926 and 52. So the paired digits were then added together. 3 plus 1 is 4, 4 plus 1 is 5, 5 plus 9 is 14, 2 plus 6 is 8, and 5 plus 2 is 7. From which a new number was generated consisting of each single digit result, or in case this of double digit, just the last digit. So here we got everything as a single digit after adding the paired numbers. If we get any double digits, in the sense two numbers, so here I got 5 plus 9 is 14. You should take the last digit of that number. So 14, in the sense 4 is the last digit, take that last digit 4. So which will be my label as 45487. The original phone number and the name or address of corresponding to it would then be put into a bucket labeled 45487. Here now the data of that person, data of this phone number, uh, uh, like his name, address, or any education information, that will be stored in the labeled bucket 45487. Looking up an entry from a phone number involved quickly calculating the bucket number using Luhn's method and then retrieving the information from that bucket. Even if each bucket contained multiple entries, sequentially searching through a single bucket was a much faster than searching the entire list. Over the decades, computer scientists and programmers have improved on Luhn's method and pushed them to new users. But the basic idea is still the same. Use a math problem to organize data into easily searchable buckets. So here is a picture of Hans Peter Luhn and how hashing algorithm has been working. First, plain text, in the sense the data which is readable, and by adding some mathematical expressions hashing algorithm in the sense adding some mathematical expression, making it unreadable form. Hashed text in the sense which is unreadable form. And types of hashing algorithm. Dozens of different hashing algorithms exist and they all work a little differently. But in each one, people type in data and the program alters it to a different form. All hashing algorithms are mathematical, uniform, consistent one way. Let's see one by one. Mathematical. Strict rules underlie the work an algorithm does, and those rules can't be broken or adjusted. So these are like the conditions which cannot be broken. And uniform. Choose one type of hashing algorithm and the data of any character count put through the system will emerge at a length predetermined by the program. So the constant length should be there. Consistent. The algorithm does just one thing, compress data and nothing else. So the specification of the algorithm must be done. It should just compress it. How do anything work? Only one work should be done. One way. Once transformed by the algorithm, it's nearly impossible to revert the data to its original state. So it should be one way, not bi-directional, like plain text to unreadable form, unreadable to plain text. It should be not like that. Just convert the data, plain text to unreadable form. It's important to understand the hashing and encryption are different functions. You might use them in concert with one another, but don't use the terms interchangeably. Hashing algorithms used for password storage, digital signature, document management, file management. Let's see one by one. Password storage. You must keep records of all of the username, password combinations people use to access your resources. But if a hacker gains entry, stealing unprotected data is easy. Hashing ensures that the data is stored in a scrambled state, so it's harder to steal. So in this way, the hashing algorithm can be used in password storage. Digital signature. A tiny bit of data proves that a note wasn't modified from the time it leaves a user's outbox and reaches your inbox. Document management. Hashing algorithms can be used to authenticate data. The writer uses a hash to secure the document when it's complete. The hash works a bit like a seal of approval. A recipient can generate a hash and compare it to the original. If the two are equal, the data is considered genuine. If they don't match, the document has been changed. File management. Some companies also use hashes to index data, identify files, and delete duplicates. If a system has thousands of files, using hashes can save a significant amount of time. Popular hashing algorithms are MD5, RIPE, MD160, SHA, and Whirlpool. MD5. This one of the first algorithm to gain widespread approval. It was designed in 1991 and at the time it was considered remarkably secure. Since then, hackers have discovered how to decode the algorithm and they can do so in seconds. Most experts feel it's not safe for widespread use since it is easy to tear apart. Next one came RIP MD 160, the Race Integrity Primitives Evolution Message Digest. Was developed in Belgium in midst of 1990s. It's considered remarkably secure as hackers haven't quite figured out how to crack it. SHA SHA is SHA. Algorithms in the SHA family are considered slightly more secure. The first versions were developed by the United States government, but other programmers have built on the original framework and made later variations more stringent and harder to break. In general, the bigger the number after the letters SHA, the more recent the release and the more complex the program. For example, SHA3 includes source of randomness in the code, which makes it much more difficult to crack than those that came before. It becomes a standard hashing algorithm in 2015 for that reason. Whirlpool. In 2000, designers created this algorithm based on advanced encryption standard. It's also considered very secure. So, conclusion. I am going to conclude this presentation. A good hash algorithm should be complex enough such that it does not produce the same hash value from two different inputs. If it does, this is known as hash collision. A hash algorithm can only be considered good and acceptable if it can offer a very low chance of collision. Hashing gives a more secure and adjustable method of retrieving data compared to any other data structure. So here is the here I concluded the my presentation. The hashing algorithm should be complex enough, and by giving any two inputs, it should not give the same output for any two inputs. That is hash collision. And hashing algorithm properties are, it should be more secure and adjustable method for retrieving data and compared to any other data structure. So thank you.